Welcome back, folks. So we're about to learn about some inscribed angle theorems and properties that will help us solve some awesome things inside of a circle. So these first two example problems will involve the inscribed angle theorem. So wait for it. It's going to be fabulous. Wait for it. All right, so this one says to find the measure of angle RST. So R to the S to the T is this bad boy down here. And eventually we'll also be finding the measure of arc S to the U. So this one right here. Okay, but in order to do this, we must think back to the Prezi video when I taught you about what the inscribed angle theorem or theorem was. So let's see what that's all about again. Let's go back to the lovely Prezi. It's kind of like a flashback, right? Like deja vu, you just saw this, I know. But anyways, so the inscribed angle theorem states that the measure of an inscribed angle is half the measure of the intercepted arc. Guys, so like this is an inscribed angle right here. Angle ABC, and the arc that it intercepts, or its intercepted arc, is arc AC. So this angle is half the measure of the arc, or you could reverse that. You could say the arc is 2 times the measure of the angle. So we'll be addressing this nifty theorem momentarily, so wait for it. It will be a blast. Let's get going. Okay, so first of all, I'm going to start with the measure of angle RST, which is this angle right here. I'll highlight it so you can see a little better. Okay, so RST is this angle right here. Okay, now what type of angle is angle RST since the vertex point is located on the circle? It is an inscribed angle. Okay, and remember you guys, inscribed angles are half the measure of its intersected arc. Which arc does the angle, the inscribed angle, intercept? Do you guys spot an arc that starts and ends where the angle will start and end? Do you see it? I think I see it. Let's look closer. Do you see the arc that angle intersects? Let's see. Or intercepts, however you want to say that. Okay, it intercepts with arc RT. So we're looking at this arc right here. So this arc directly relates to that angle. Guys, so I'm going to set up a relationship between that angle and that arc using the inscribed angle theorem. Sorry, I want to adjust this to make this a little bit better. But anyways, so I'm going to set up a statement that will show the relationship between the angle RST and its intercepted arc, arc RT. So what do you have to do to the arc to get to the angle? Because I'm going to be solving for angle RST. So what can I do? I already know the measure of arc RT, which is 120. What do you do to this angle to get to the intersected arc? To get to the inscribed angle. Sorry, the demon cat's got me. You do divide it by 2. Okay, so if you know the inscribed angle, you double it to get its intercepted arc. If you know the intercepted arc, you half it to get to the angle. So I'm going to set up a statement that represents that. Okay, so I'm going to say the measure of angle R to the S to the T equals 1/2 the measure of its intercepted arc. So the measure of arc R to the T. Bam. All right, and then after that, I can quickly solve. So let's get this bad boy solved and on the road. Let's go. All right, so I'm going to fill in these values, which I don't know what RST is. That's what we're solving for, right? So I'm just going to write the measure of angle RST equals 1/2 the measure of arc R to the T, which what is the measure of arc R to the T? It is 120. So it's 1/2 times 120, or half of 120. So guess what, you guys? What is half of 120? Holy hot dog. It is 60 degrees. So the measure of angle RST is 60 degrees. And guess what, you guys? The first one is solved for, so we are done with that first half. Nice. All right, so moving on to our second part, now I want to find the measure of arc S to the U. So let's see if maybe we can have another inscribed angle that might just help us find the measure of arc SU. I don't know, though. We'll have to see. You know, I want to be optimistic, but I don't want to get my hopes up. So let's see. So we have arc SU right here. I'm going to highlight it again. So this is arc SU, do you see any angles in the picture, particularly any inscribed angles, that might help me to find the measure of the arc SU? Do you see the angle that intercepts the arc? So SU is an intercepted arc of an angle. Do you see it? Do you see it? I see it too, you guys. Oh man, it is 40 degrees. So inscribed angle SRU, okay, relates to this arc. This is the intercepted arc of angle SRU. So I know that if I double the inscribed angle, I will get the value of its intercepted arc. So let's get going. Oh man, this is so exciting. Gotta be fast, gotta be fast. Go, 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 go. Ugh, this angle is irking me. Sorry, guys. Want to make sure we're at a good angle. It's all about those angles, right? Geometry joke. But anyways, let's get going. Okay, so I want to find SU, arc SU. So I'm going to start with the measure of arc SU. Okay, what do we do to the inscribed angle SRU to get to the intercepted arc SU? We do, in fact, double it. You guys, like normal, are on a roll. Okay, so I'm going to multiply angle SRU by 2. Oh, whoops, I didn't put the angle. Sorry, guys. Come on, demon cats, don't get me already. Okay, so 2 times the measure of angle SRU. That's the proper way to write that. Sorry, guys. All right, but anyways, let's get going. So I'm going to bring down the measure of SU, since I don't know what that is. I'm solving for it. Equals 2 times the measure of angle SRU, which I do know. The measure of angle SRU is 40 degrees. And what is 2 times 40 degrees, you guys? It is, in fact, 80 degrees. So the measure of arc SU is 80 degrees. And guess what, you guys? That's all, folks, on that one. Let's get pumped up for example 2.